What the yo? What's up? I don't know what just happened right there. What? Wait, is there another stream going on into my app? What? Let's go. Wait. Let me just check. Totality high. Yes, there is a live stream, of course, going on. Oh, okay. Okay, that's great. I gotta delete that there. It says that there was a problem playing the live stream. So, yep. I don't know what just happened right there. I think it was saying OBS was already running, and then once I canceled that program, it literally canceled the other one. Like, dude, what? And then when I started opening, I started the other live stream, because it did not even show me the resume interrupted stream. It literally ended that stream. Like, dude, what? I was so confused at that point. Anyways, if you guys are wondering what I'm doing, I'm still doing physics practical because my physics practical exam and chemistry practical exams are approaching. Tomorrow is my chemistry practical exam, and day after tomorrow we will have physics practical exam. So yes, we are gonna lock in right now. Anyways, we are gonna actually still do this precaution. Let's do that. Bro, like, whoa, man, that was crazy. I was like confused for a moment. I was thinking, what is going on exactly? Then I'm fine right now. It's not a big problem. It's not a huge thingy. But yes, anyways, we are still fine. I want to ask one of my friends to actually send me a graph, basically, because we need to have the graph for that one, right? So yes. Oh dang, dude, I gotta really use the WhatsApp carefully. So we don't have any tests, any theoretical tests, but yes, we have practical tests, and we have to be really careful for that. Alright, so pulleys should be frequent. Okay, this is basically the precaution I'm writing, meaning it means that I'm gonna end my fourth experiment. And the only two experiments that are left now is vector laws of parallelogram and the simple pendulum, the toughest one. But the problem is right now I can actually easily complete the vector laws of parallelogram because it's an easy experiment overall, but the accuracy and all that stuff is very important. It lies into it. Now what's my next plan? You might be thinking, what's going on? What's gonna be the next thingy that is gonna take place over now? Right now I'm thinking of actually starting off my chemistry practical preparation again. I have to revise it. I have to go through my practical table. I believe that I've completed the whole thing. I gotta just go through and memorize the whole stuff. I'll give myself one more hour of time and I will practice it. Then we will go through Viva, because we need to actually have that idea of what is gonna be there asked and what is the main stuff. We know it's gonna be asked inside the table. It could be asked outside the table too, so we have to be really prepared for that too. Yeah, we gotta be really prepared for that. So let's just do it. We're gonna have an idea based on that. So pulleys should be frictionless. All right, I don't know. Yeah, this is gonna be fun though, that's for sure. If any one of you guys are wondering what is going on with Robert W, basically he's actually right now moving into his new home. His new home is actually he has a lot of work related to that, so he's gonna take a bit of more time. I'm not sure at what time he'll go live because he's very busy. So please give him some time. I hope he's gonna actually make a big comeback. Also, he has a lot of tests coming up, so I think he has to lock in though. But the problem is he has also have to really focus on his new home. So basically he's gonna shift. I want to really see the background, next background of his live stream. It's gonna be fun because that's gonna be interesting and great. I hope so. But yeah, overall I'm excited. But the thing right now here is that we have to overall actually now have to get this thing done. Alright, it's gonna be not that easy, it's gonna be not that hard, but at the same time we have to actually focus on our practicals now, physics practicals. So yep, note down the weight when roller is about to move. Actually, it's when the block is about to move. In reality, it is actually the roller we need to use here. What is going on? Okay, I will explain what is happening here. We have an experiment that actually we have to find the frictional force, and we have to give a graph for friction and the angle. There's an angle called as angle of repose, and we have to also give sine theta, that is the sine of angle of repose, and we have to plot a graph for that too, like this kind of graph. I can show it to you. I'm not sure if you can see this, but this is the graph basically. You see these two graphs, this one, and there is another one, this one. So we have two graphs and we have to plot them, and I even made a graph for that too. So yes, you can see those graphs, like you can you see those? Yeah, this is the graph I've plotted overall. I mean it's easy because it's not that hard experiment, but then there's another additional experiment. There we have to like calculate and do all that stuff. So yeah, this one is very easy overall. You don't have to do much anything on this. There's no calculations, nothing. You just gotta get the readings, observation, and you gotta plot it in the graph. Overall, this is very easy to do. Anyways, yeah, that's it. The biggest advantage for us is that there is no activity for us to do. Not any activity. So we are just really fine to do with anything what we need to do. Yep, that's it. Okay, wait, what? Alright, I don't want to waste my time. Base of inclined plane should be horizontal and stay. Base of inclined plane should be horizontal and stable. And yeah, you may be thinking, what happened yesterday? Yesterday, my mother is basically working. You know, her school, she's basically a teacher, okay? So her school had an exam conducted recently, and the exam has already been over. So they actually completed the exam, and of course the teacher has a lot of burden of correcting all those papers, and she has to even enter the marks into the system. So she has to like log in and do this through the laptop by making an Excel sheet from the Microsoft. She has to like create that, or I'm not sure, not exactly about that, but yeah, she has to enter it into the system for the school. That's the thing. That's why she's taking a lot of time. Of course, it's gonna be a burden for every teacher. After every exam paper, they have to check and do a lot of corrections. But yeah, that's the thing. All right. Okay, so can I actually write this down? I'm not sure that it's possible or not. Yep, increase the weights and small stuff by small amounts initially, I would say, because in many experiments what they do is basically they just actually increase it gradually. Now I have a small doubt, man. I gotta like check the graph too. There's a big doubt I have right now. Let's check the graph. Okay. Okay, let's check the graph. I have to check the images. Okay. No, wait. What is this? No, wait. I understand what they're trying to do in this graph. I understand. I'm gonna show you that graph. Wait a minute. Let me open the display capture. Alright. I understand what they're talking about here. It's the static friction. There is this limiting friction where it is max, and then it goes down, and then the kinetic friction takes place, which is parallel to the x-axis. I understand what's going on here. Also, the reason why this takes place is because the kinetic friction is lesser than the limiting friction or the static friction. That's what is explaining here, by the way. But the thing I'm actually talking about is not this one, by the way. What? Okay, wait. I need this one. Let's check this one. What does this explain, by the way? Yeah, this one is good. Okay, this looks like a practical one. I like the practicals one. Alright. Okay, there is an increase here, and there is an increase right there. 0 and 8. We take this. The thing is that I'm not sure. I mean, I might have made a small mistake in the observation table. That's what. I have so many doubts. Like what? There's a big doubt for me. I have to really solve this as soon as possible, or else I'm gonna get cooked. That is gonna be a really big problem right there. Man. Anyways, I think it's time to start off the chem practical, and then we'll continue with our parallelogram law of vectors. It's easy. I can actually complete it under half an hour or 1 hour, but then simple pendulum, you gotta give that a lot of time. It's not gonna be that easy. That's the most challenging one. Alright, let's start off with the table. We are gonna write the table here. Let's make this. Okay, never mind. We are gonna put the serial number here. Alright. Okay. Then we're gonna make this kind of column. Alright. This is gonna be wait a minute. This is gonna be wait a minute. Let's just check. Serial number. And this is gonna be our experiment or observation. Experiment. No, wait. Oh no, wait. There is experiment, I know for that for sure. Well, like, there is observation too. Okay, never mind. I mean, I'm correct. Alright. No, never mind. I'm not bad. Okay, let's go. One. Experiment. Let's start with this. Color. Colorless. We're gonna write the whole table down. Light pink, bluish green, then pale green, then light brown. Okay. Absence. Colored cations may be absent. Alright. Mn2 plus and Cu2 plus. This is Fe2 plus, and this one will be Fe3 plus. May be present. Maybe. I mean, I really hate writing like this repeatedly, but I have to do it. Dang, dude. I just gotta practice this. That's the thing. May be present. Alright. May be present. And this is preliminary test. Salt analysis. I forgot to write that. This is the whole table I'm writing down. Not any kind of specific salt. So yeah. Preliminary test. Alright. Check that out. Fe3 plus may be present. Now what's next? We gotta check the odor now. For odor, we might have the idea about, well, let's write this down. We could either get odorless or no smell. We can get Vinegar. Okay, wait, I will write pungent smell first. Pungent smell. Vinegar like smell. Alright. Here odorless and vinegar like smell. Now what I'm gonna do, I'm gonna write here absence of a, okay, first of all we'll write the, mention this. Pungent smell will be Cl minus may be present. Here we can write CH3COO minus may be present. Alright. This one, odorless, absence of may, no wait, Cl minus and CH3COO minus. CH3COO minus may be absent. May be absent. I want to write that down here. Alright. Next, what we're gonna do here is dry heating. Alright. Next, dry heating. Okay. In dry heating, we could either get odorless, no smell. I'll write no smell this time. We can get pungent smell, and I'm gonna leave some space here, alright, because there's a condition I have to mention. Then we can write here brown gas. Is released. Alright. Now there is a confusion actually. There is a lot of confusion here, okay? What is going on is basically okay, wait, you know what? Let me first actually write this down. Before even writing no smells inference, I'm gonna write down the pungent smell part. Dipper rod, glass rod in NH4OH and pour it on sides of the test tube. On sides of the test tube. Alright. That's it. Dip a glass rod in NH4OH and pour it on the sides of the test tube. We got it. Now no smell. No smell meaning that there is we can say there is absence of these two ions. Okay, brown gas. Okay, Cl minus may be present if but there is a condition we need to know. Alright, that pungent smell can be released by many salts actually. Okay, but in those salts there is a chance that Cl minus may not be present, but still they're releasing this pungent smell. So the thing is that there will be confusion by many students, that they will be thinking that there is Cl minus present and they will directly write it down. But there is a condition that we have to follow first. That we first need to dip a glass rod in NH4OH and then we have to pour it on the sides of the test tube. Why is it's because that we'll get sometimes the pungent smell, but if the NH4OH when it's poured on the sides of the test tube but does not release that white fumes, then those white fumes are not released, we cannot say that Cl minus is present. Alright, any other anion might be present, any other cation might be present that is having that similar properties of pungent smell. Alright, so we shouldn't be actually detecting it like this. Alright, there's a thing you should have an idea, like suppose I say NH4Cl. okay, no, not NH4Cl, let's take another salt. Let's take it's ammonium sulfate, NH4 twice SO4. okay, this salt is really interesting. If you do an experiment in dry heating, you actually get a pungent smell. Alright, this is an interesting one. You get a pungent smell, but now many people will be thinking Cl minus may be present, right? No, because there is no Cl minus, of course, in that salt. Of course there is no Cl minus, but then there's how is that pungent smell produced? We have to detect it first of all. Okay, because NH4 plus is also having this characteristic of actually producing the pungent smell. But then there are many people who will get confused. Alright, So how do we? So the thing here is that first you need to dip a glass rod in NH4OH and pour it on the sides of the test tube. Once you do that, you will realize that it's actually not showing white fumes, meaning that the Cl minus is actually not present. Even though it's giving pungent smell, it's not actually Cl minus because it's not giving that white fumes. Okay, so white fumes should be released. If it is not, then there is a really great chance we know that this is not possible. All right. Now the pungent smell, that's what we need have an idea. Okay, brown gas is released. Okay, if that is released, then NO3 minus may be present. All right, NO3 minus is could be present. Okay, no smell, meaning that there's Cl minus and NO3 minus may be absent. All right, may be absent. There's a chance. Now let's do the talk about the flame test. All right, this is the biggest confusion that everyone has. Also, yeah, there's another confusion about NH4 plus and Cl minus. If you look at the odor of and you get a pungent smell, don't think it's Cl minus, because that's a really big mistake that many people think. In the odor test, if you actually smell the salt and you get pungent smell, it's not Cl minus actually. It is the NH4 plus, because Cl minus first has to get released in order to give the characteristic of pungent smell. Cl minus, when it is bonded with any other with another cation, that will not show that pungent smell at all. So that's the thing actually. So that's the main idea we need to have based on this. So yes. Alright, now next is flame test. Okay, flame test. In flame test, what we are exactly doing is that, first of all, there is flame test, right? Okay. First of all, we'll actually suppose say no characteristic flame here. Alright, suppose, just write it down here. Now this one is interesting actually. This one, flame test, is really interesting. If you actually get a characteristic flame of a color, okay, any color, it could be any kind of color, you can look at the flame test. If you get any color, all right, and it detects an anion, or sorry, my bad, cations are only there for flame test. All right, my bad. You can directly confirm that cation. Why? Because flame test also acts as a confirmatory test for some cations. So whenever you actually see a cation present in that salt, of course you may not detect it because you haven't done the experiment yet, but if you actually get the flame test of that cation and it is showing that this could be there, then you can just confirm it directly. Why? Because this flame test acts as a confirmatory test for these cations, and that is very specific for each and every cation that it shows. All right, if the flame color is silvery white, once you take a glass rod and okay, wait, I have to also I forgot to mention that, make a paste of salt with concentrated HCl. Okay, you have to use the glass rod for this. Okay, or you can use another apparatus, I forgot that name, not apparatus, another kind of tool that is used for this flame test specifically. All right, no characteristic flame, meaning that there is those cations are absent, but silvery white. Now silvery white color shows that Pb2 plus may be present, or you can just say it's confirmed. It is confirmed actually, not gonna lie, it is confirmed. Then you can say crimson red is another one. Crimson red is like purpley red color. Silvery white, it's very bright white flame. That how you do it, like example, how you get Mg plus O, right? Once you react, you get MgO, and that is how you actually get combustion reaction going on. And that combustion reaction, you see a bright white flame going on. That bright white flame is just basically similar to this color, silvery white. All right. Crimson red is, however, purpley red color. That is Sr2. That is strontium may be present, and it is a real cool color, by the way. I actually observed it in the laboratory. It's very good. It's very good. Then, after crimson red, we got another one. All right, brick red color. Brick, or we can let's go with brick red. Brick red color, however, is Ca2 plus. That shows it could be present. All right. Ca2 plus may be present. Alright. Then we got apple green. Apple green we can say that there is a chance where, okay, wait, Bb2 plus, Sr2 plus, calcium 2, yeah, barium 2 plus, barium 2 plus may be present. If your flame color is dark bluish green color, it's dark bluish green in color, then that one is basically Cu2 plus that is present. May be present, but then yeah, except for Cu2 plus, by the way, because Cu2 plus will actually exactly not confirm it, because Cu2 plus has multiple characteristics. That's why. So yep, you cannot actually trust Cu2 plus. You gotta do another experiment for that for confirmatory. But except for Cu2 plus, all the others can easily be confirmed. Remember that. All right. So yep, Cu2 plus is an exception. If no characteristic flame, we can say Pb2 plus, Cu2 plus, Ca2 plus, strontium 2 plus, then barium 2 plus may be absent. Alright, if it does not show, you have to just move on, man. That's it. Alright, now test for radicals or test for anions. This one is also important. This one is kind of confusing for some people, and let's try to resolve that too here. Alright, first of all, let's make the table again. From this, we're gonna make a serial number. And then we're gonna put this up to here. This is gonna be our experiment, this is gonna be our observation, and this is gonna be our inference. Let's write down here this stuff. Alright, serial number, experiment, observation, and inference. It's gonna take a bit of time, but I hope so this works. Okay, let's start with one. Now we are actually starting with salt, where we will add it with dilute H2SO4. Okay, dilute H2SO4, and it's not harmful. You can be fine with it. It's not gonna hurt you much. It's gonna do anything. Yet you might feel some gentle burn, and that does not affect you at all. It's just better to wash your hands. That's it. Alright, this will have either no characteristic, okay, no characteristic, or brisk effervescence. Brisk effervescence. Yo, what's this, man? The pen. No characteristics. Okay, let's start. So SO3 if there is a brisk effervescence, then SO3 minus may be present, or CO3 minus may be present, or S2 minus may be present, or NO3 minus may be present. So yep, these are the 4 anions that are having a chance of being present. But if there's no characteristics, then we can say SO3 minus, CO3 minus, 2 minus. It's SO3 2 minus, my bad, right? Is it? Let's see, man. SO3 2 minus, CO3 2 minus, S2 minus. I hope so. It's 2 minus for that charge, for that anion, and NO3 minus. My bad. May be absent. That's it. All right. Now for salt plus concentrated H2SO4, there are 2 sectors for this one. All right. There are 2 sectors for this. First one is without heating, and the second one is with heating. First one is without heating, second one is with heating. Oh wait, you guys cannot see, my bad. I did not observe that. I'm just checking it right now. With heating. Now, if we're actually doing it with yo, can you hear me, guys? Oh dang, dude, what the hell was that? Anyways, I'm not sure whether the stream is continued or it is another live stream that is taking place. Anyways, I have been doing the confirmatory test for anions. I'm still at bromine. Okay, I did not move further. I just wanted to like fix this up. Anyways, let's move on now. Dilute HNO3 plus AgNO3. This one should give us full yellow PPT, and that is insoluble in NH4OH. That gives us this confirmatory test for iodine anion. I minus is confirmed. Alright, this is the thing. Let's go. 6. Let's go with sixth one. Wait, what's the sixth one, by the way? Did we check all of these? Let's see. We had done this, and this. What else is left? CO3. Yeah, CO3. CO3 2 minus is confirmed. And there is not specific experiment for this. I'm so confused because in the salt analysis PDF it's actually left alone. It gives you brisk effervescence that is released. Effervescence released from the mouth of the test tube. I might have to refer for this one. From the mouth of the test tube. This one is a different case from the test tube. Like you're just gonna add up here. I could say suppose salt solution plus that and this, but no, it's not given. It's not exactly mentioned, so yep, I gotta like, take that up here. Anyways, it's fine. We're all doing great. Let's just keep blank here. Okay, it's gonna be blank here. I'm not gonna put anything here. Now I think there's another one, last one, that is for CH3COO minus. So far I did not get any salt from CH3COO minus anion, so I'm kind of doubting it, but let's see, man. I'm not sure about that one. Seventh one, salt solution plus FeCl3. That is giving us red coloration, and that red coloration is due to the presence of CH3CO minus, and thus it confirms it is confirmed. I can say freshly prepared FeCl3, and that's the confirmatory test for anions overall. Now a group-wise analysis of cations. This one is the easiest one of all. It has a pattern, so I can easily do this, and confirmatory test after that is a bit difficult one, especially the GP5 one, man. Kind of confuses me a lot. Let's just do it. Let's start off with up here. Okay, let's keep this here. Okay. Alright. Serial number. Then we got experiment. This is the easier one. I can easily do this. I have no doubt about it. Observation and inference. Let's start. Salt solution. I'm not saying this overconfidently, but yeah, I have practiced a lot. That's why I'm saying this. Salt solution plus dilute HCl. If it is showing white PPT, then you can say GP or no characteristic observation. characteristic observation. This one will give us the actually I feel like group wise analysis except for GP0 all the GP1 I have to okay I have to mention that too. This is GP1 that is your PB2 plus may be present. Oh wait, oh yeah, that is a bit tricky here. I cannot do this here. May be present. And GP1 PB2 plus may not be present. May be absent. Now there's a big doubt here actually because I'm not sure whether I have enough space for it. But yep. Still can write this down, bro. Right? Like, can I do this? It's gonna take a lot of space, so let's just risk for it. Okay. We're gonna take a small amount of space here. Then we're gonna write here the 2. GP2. Salt solution plus dilute HCl plus H2S. Alright. This will give us either wait, let me think about it. Yellow PPT. Then we have black PPT. Or no characteristic observation. Or no characteristic observation. Alright. Yellow PPT, okay? So yellow PPT will give us the presence of GP2. CD2 plus GB2 plus CD2 plus may be present. Now GP1 GB2 CO2 plus may be present. Maybe present. Or GB2 may be absent. Now let's move on for the third one.
Let's move on to the third one, everybody.
This is gonna be the serial number. This is gonna be the experiment. Oh, I'm actually making a big column for serial number. I shouldn't be doing that. Observation and inference. I still somehow managed it. Let's go. Third one. Salt solution plus NH. Wait, is it yep, alright. NH4Cl plus NH4OH. If that does not give us the required PPT, we should be getting white gelatinous PPT. Or B, that is no characteristic observation. No, dude, this is running out of ink. Might have to take another pen. Okay, alright, let's do this. GP3 AL3 plus may be present. Wait a minute, guys, I'm coming back, okay? So let's start with this. Salt solution plus
Hi.
alright, let's go back. Plus H2S. From this we should be getting our wait a minute, guys. Oh, wait, what? Hmm. Hmm. Oh, wait. Let's go. Yeah, this is GP4, so ZN2 plus will give us dirty white precipitate. That is dirty white PPT. Or it could be giving us flesh colored PPT. Flesh colored PPT. If that is giving us this one. Alright. So GP4 ZN2 plus may be present. Or GP4 MN2 plus may be present. Or no characteristic observation again. GP4 may be absent. Okay, let's go. Fifth one. 51. Salt solution plus NH4Cl plus NH4OH plus let's this time put ammonium carbonate, so NH4 twice CO3. That should be giving us a white PPT, and that is basically just giving us GP5 may be present. Still, there are still many. This is for GP3. This is for GP4. And this is for GP5. Salt solution plus NH4Cl plus NH4OH. We gotta put this alright. We gotta not give up. We gotta lock in. Lock in, guys. Lock in, alright? Salt dilute solution plus NH4Cl plus NH4OH. NH4 thrice PO4. This time we're gonna put ammonium phosphate. This is interesting. We again get white PPT again. This one but gives us okay for GP5. If there is no characteristic observation, you can just say observation, which means basically wait a minute. The GP5 is absent. GP5 could contains Ca2 plus, barium 2 plus, and strontium 2 plus. The YPPT just gives us the idea that GP6 is present. That is Mg2 plus basically. GP6 may be absent if no characteristic observation is there. The last one is GP0. This one is different from all the other GPs. That is GP0. You basically just put salt, not salt solution, plus NaOH, and there is a requirement for it. If you actually get the outcome from it, wait, you have to first actually took salt and NaOH, okay? Then try heating it. It's better to heat. It says heat if necessary, alright? And you can do concentrated HCl. You gotta put white fumes are produced when concentrated HCl is slowly poured through the mouth of the test tube. Got that? Alright. This will give us that NH4 plus GP0, that is NH4 plus, that is present, may be present, or if there is not any kind, then no characteristic observation. That's what I would say. Yes, okay.